Hi, it's Mrs. Tellas. We're going to talk about section 3.3 today, which is functions. When we're done with this, hopefully you'll be able to understand that function notation is the same thing. F of x is the same thing as y. We're going to evaluate N for function notation, and we're going to graph linear functions on a table. So let's start right here. All right, so function notation is another way of writing y. Function notation is f of x. So I'm actually saying f and then the word of and then x. So that right there, f of x is how we say that. So it's the same thing. These are two linear equations that are written exactly the same. Y equals 3x minus 8 and f of x equals 3x minus 8. These are the same. This is written in function notation over here. Okay, so they're the same thing. They're going to graph the same. They're both linear. Okay, so the first thing you had to do was understand that y and f of x are the same thing. So now I'm going to evaluate. So it says to evaluate f of x equals 2x minus 7 when f of 4. So what I want to do is I want to take this 4 and I want to put it in place of the x, or I want to substitute it. So I'm taking the x out and I'm putting the 4 in. So this will be 2 times 4 minus 7. Well, you can just type that right into your calculator and that will give you 1. Okay, and then if I do the same thing here, I take the negative 4 and I put it in right here. So 2 times negative 4 minus 7. Type that right into your calculator and it will give you negative 15. And that's the answer. Okay, so it's a plug and chug kind of thing. So I want you to press pause and I want you to try 2 and 2a and see if you can get those right. Use your calculator. Don't guess on the integers. All right, so if we try 2, we're taking the 3 and we're putting it in here for x. So negative 3 minus 1 is negative 4. If you got that right, give yourself a pat on the back. And we're taking this function and we're taking the negative 1 and putting it in there for x. So negative, because there's 1 here, negative 1 minus 1. Well, these two make a plus, so that's 0. So the answer is 0. So those are plug and chug. You figure out what you're going to put in place of x, you put it in, and you use your calculator to chug it out. Okay? All right. So now we're going to go here. So it's the same thing. I've just got a fraction. And you can see also that I've got g of x and h of x and r of x, but they're the same thing. I'm just going to take the negative 4, plug it in, take the negative 8, plug it in, and take the 4 and plug it in. Why don't you press pause and try all 3 of these? Use your calculator, don't guess, and come up with 3 answers. And then we're going to graph. So if I do 1/3 times negative 4 minus 2, and I use my calculator, my Desmos calculator. So 1/3 times negative 4 minus 2 gives me negative 3 and 1/3. That's my answer. Okay, if I take that negative 8 and put it in, 6 times negative 8 plus 9. So again, use your calculator. So negative 48 plus 9 would be negative 39. Okay, and then here, negative 4 plus 9 is 5. So if you got any of those right, good job. Give yourself a pat on the back. And let's graph. All right, so when we graph functions, remember that this is the same thing as y equals 2x plus 5. We learned in chapter 3.2 or section 3.2 that that's going to be linear because it's in slope-intercept form. The y has an exponent of 1, the x has an exponent of 1. Remember that f of x and y are exactly the same thing. Okay, so we can take some random values, and we want to pick easy values because we want them to fit on our graph. And we're going to put them in place of x. And we did a little bit of this in chapter 1, where I would give you the domain, and you would come up with the range by using a table. This is really the same thing. Okay, so we're going to take this, start with 0, and I pick 0, 1, and 2 because those are easy numbers. And I'm going to put it right in there in place of x. So 2 times 0 plus 5. And you're going to type that right in your calculator. And when you do, you get 5. The input was 0, the output was 5. So the ordered pair is 0, 5. And then I'm going to do the same thing with the 1. The input is 1 this time, and let's see what the output is. 2 times 1 plus 5 is 7. So my ordered pair is 1, 7. And then on the last one, I'm using the 2. So 2 times 2 plus 5 is 9. So 2, 9. Now I can use my graph paper and 0, 5. So that would be going from the center. I would go sideways 0 and up 5. 1, 7 would be right 1 and up 7. And 2, 9 would be right 2 and up 9. And you can see that makes a straight line. So I'm going to draw a straight line through all the points, and I'm going to put arrows on the end because it doesn't make a straight line segment. It makes a straight line. So there's my answer. The table and the graph are my answer. All right, let's try another one. All right, this time you press pause and you create the table and make it. Use 0, 1, and 2 again because those are easy numbers to graph. And you try to come up with the y's, the points, and graph the table. All right, so x goes here. Our function, I'm going to change it to y. I like y better than h of x. 3 minus x. My y, my answers or my outputs are going to go over here. And then my ordered pair is last. So I'm going to use 0, 1, and 2 again because they're easy numbers to deal with. And I know I can graph them very easily. If I pick 100, then I have to have a graph that has 100 x's on it. That would be huge. So I want to pick a nice small numbers. So if I take my 0 and plug it in right there for x, this would be y equals 3 minus 0, which is 3. So 0, 3 is my first point. If I take my 1 and plug it in, y equals 3 minus 1, which we all know is 2. So 1, 2. And if I take the 2 and plug it in for x, y equals 3 minus 2, which is 1. So 2, 1. So now I can graph it. And keep in mind, if when you graph it, you get a check mark or an angle looking thing, something's wrong. It's probably in how you graphed your points. Okay, supposed to make a straight line. That's linear. Okay, it's linear. So if I go make my points, 0, 3 would be sideways 0 and up 3. So up 3. 1, 2 would be right 1 and up 2. So far it's looking very line-like. And 2, 1 would be right 2 and up 1. Yep, it looks just like a line. So this is my answer. And I just put my little arrows on the end. And I'm finished. Okay, one more. Let's do this one, number 10. So this says h of x equals 2/3 x minus 5. Well, it also says y equals 2/3 x minus 5. Okay, remember, h of x and y are exactly the same thing. So usually I use 0, 1, and 2, except when I have a fraction. Because if I put 0 in there, I'll be okay. But if I put 1 in there, I'm going to get a mixed number for my answer. And I don't want to graph a mixed number. So what I can do is I can take multiples of the denominator and use those. Now 0 always works. Okay, so let's put our 0 in. So x and then y equals 2/3 x minus 5 and then y and xy. And then instead of 0, 1, and 2, I'm going to do 0 and then I'm going to do 3 because the denominator is 3. And then 6, because if I count by my 3s, 3, 6, 9, 12, I want to do multiples of 3. If I do multiples of 3, it will come out as whole numbers, which is what I'm wanting. I don't want to have to graph fractions. Okay, so here we go. Y equals 2/3 times 0 minus 5 is -5. So 0, -5. Let's do the 3. Y equals 2/3 times 3 minus 5. Now, if you stick that in decimals, which you should stick it in there, you get -3. So 3, -3. And then the last one, if we do the same thing with 6, 2/3 times 6 minus 5. Let's see, that would be -1. And we have to stick it in decimals to figure it out. Okay, so if I go graph it now, should make a straight line. If it doesn't, something's wrong. So 0, 5 would be sideways 0 and down 5. 1, 2, 3, 4, 5, right there. And then 3, -3 is right 3 and down 3. And 6, 4, 5, 6, down 1. Isn't And that makes a straight line, so I know I'm right. Making that straight line is kind of like my check to make sure that I know what I'm doing and that I am correct. All right, that was the last graph. So now we're going to do the story problem. Here's the function right here. D of t, which is the same as d of x, equals 186,000 t. So it tells us that light travels about 186,000 miles per second. The equation that I just read gives the distance d of t in miles that travels in t seconds. So this part over here stands for distance or miles. And the t right there stands for seconds. So in the question, they're either going to give me the distance, and I'm going to put that in for d of t, or they're going to give me the seconds, and I'm going to put that in for t, and solve. So let's see. It says, how far does light travel in 30 seconds? That means that goes here for t. So d of t equals 186,000 times 30. And I use my calculator. So let's type that in. 186,000 times 30. That gives me that the distance, d of t, is 558,000. So 5,580,000. And that would be miles. And you can put the label or not, completely up to you. Okay, and then I'm sure B is the other way around. Yep. So this time it's giving me the miles. So I take that same equation. And this time, because it's giving me miles, I'm going to put it in here. So 3,720,000 miles equals 106,80,000 t. If I want to get this t by itself and they're multiplied, hopefully you know that we have to divide. So we're going to divide both sides by 186,000. And we're going to stick it in the calculator because nobody knows there are 186,000s. All right, so that would be 372 and 4 zeros divided by 186 and 3 zeros. And that gives me 20. So 20 is 20 seconds if you want to label it, although it's not necessary. All right, so hopefully now you understand that f of x and y are the exact same thing, that you can take numbers and plug them in into the function notation and come up with answers, inputs and then outputs, and then you can graph. Okay, graph and function notation, which just use 0, 1, and 2 unless it's a fraction. And if it's a fraction, use that denominator, 0, whatever the denominator is, and then whatever the denominator is times 2. Put it in, use your calculator, and come up with the outputs or the y's. So, okay, thanks a lot. Have a good day.